Trigonometry involves triangles. It relates the angles in a triangle to the sides of a triangle. In the series of videos on trig formulae, it's going to rely on a triangle labelled A, B and C, as you see, with sides small a, opposite angle capital A. Here are the pairings. Side A and angle A are opposite to each other. Opposite angle B is side small b. Opposite angle C is side small c. I'm going to look at the ratios A to the sine of angle A, B to the sine of angle B, and C to the sine of angle C. So it's the values of these ratios. Now, this software will fill in the angles that are missing. It will fill in the sizes of the sides. It will divide the size of side A by the sine of the angle A and work out the answer to that. I'll do it for each of the sides. So here, this red line 7.3, the opposite angle is 44.8. 7.3 divided by sine 44.8 comes out rounded as 10.3. Calculations for the blue side is 8.3 over sine 53.6, and it's also 10.3. And for the black side, 10.2 over sine 81.6, and it's 10.3. So the value of the ratios is the same for the pairing side and sine of opposite angle. Now, if I adjust this triangle, changing the angles, you can see the ratios staying the same. Sides are changing, angles are changing, but the ratios are not changing. 7.5, 60.2, there's the ratio, 8.7 for all the sides. So this software calculates the value of the ratios as the triangle changes, but the ratios, when they're calculated, always come out the same. In other words, that's the case. The ratio A to sine A for that pair is the same as B to sine B, C to sine C. That's the sine rule. That's what you memorise for a triangle ABC. There it is there. So this triangle, there's the ratios. If you know one side and the opposite angle, you can work out the value of the ratio. So the other ratio here should be the same. So if you knew side B, you could work out angle B, knowing you get the same ratio. Or if you know angle B, you can work out side B. So you know one pair, you can get the ratio, and for one other piece of information, angle or side, you can work out another piece of information. Here's an example. Find QR in this triangle. That's this side here from Q to R. What lets you know it's the sine rule is the pairing 6 and 55 degrees. They're opposite each other. That lets you know the sine rule because you've got a ratio A to sine A. That means you can work out the value of that ratio. And the other sides here, QR is opposite P. So this side here that you're trying to find out would pair with this angle. Now you actually know this angle because the triangle makes 180, 82 and 55. So that's 43. That makes the triangle up to 180. So you know 43 degrees. You can figure out the missing side using the sine rule. So going to get rid of the lettering, going to get rid of the 82 degrees because all we need is the 6 and the 55 degrees go together and the A and the 43 degrees go together. Now I'm going to put the 43 degrees as A because it's on the left here, and I want the letter I'm trying to find out to be in the top left because the equation is easier to solve that way. And the pairing I know I've made the B. So there's 6 and sine 55 in red. There's the A and the sine 43 in blue, and I put the A to be the unknown, so it's in the top left of an equation because that's easier to solve. Multiply both sides by sine 43 and they will cancel off on the left, or if you like, division on the left by sine 43 becomes multiply by sine 43 on the right. So the equation is easier to solve when you put the letter in the top left. Put that into the calculator. There's the unrounded answer. It's rounded off. The side we were after original was QR, which is labelled A. So it's QR is 5.0. So that's find a side. You need the pairing. You need to know the angle opposite to the side you're after. And you remember a triangle makes 180 degrees. So if that angle wasn't there, you could work it out. So that's find a side. Here's find an angle. So again, triangle PQR. This time we've got two sides. We know a pairing. So that tells you the sine rule. We've got this side 5. So on the other side we've got. So that means we can work out the angle opposite to it. There it is. We can work that angle out. We can calculate it using the sine rule. And because we're after an angle PQR, that's not quite the final answer then to get P, because we make the triangle up to 180 and that gets us Q. So if it's P you were asked to work out, it'd just be apply the sine rule, and it happened to be Q, you get the answer for P, and then Q's making the triangle up to 180. So there's the essentials of what we need: the pairing, 6 and 55 degrees, and the side we know, 5, and its opposite angle. So again, I'm trying to get angle A, so I'll make it the top left. To make it the top left, I had to flip the sine rule upside down. These ratios are equal. So sine rule flipped upside down simply to get the angle on the top. So it's sine A over that 5. That's that pairing. And it's sine 55 over that 6. That's the pairing we know. That is division by 5. Multiply by 5 on the other side. That's equivalent to multiplying both sides by 5. Put that into the calculator. Don't round anything. That's what sine A is. To get rid of that sin, you inverse sine. There's an unrounded answer. It's 43.049 and so on. There it is in the diagram, 43 degrees. 43 and 55 and the missing angle have to make 180. So there's the unrounded answer, and there it is rounded off to 82.0 degrees. So the angle up here at Q was 82 degrees. So that's find an angle using the sine rule flipped upside down. Now, when you inverse sine this number, you can get 43 degrees. Equally, it could be 180 minus 43. It's supplement. That could be an answer as well, but because we can see in the diagram that this angle is acute, it's obviously 43. So it's not 137, it's supplement, which would be an alternative answer. So that's the sine rule. Two kinds of question: find a side, find an angle. But you've got to remember a triangle makes 180 degrees. This is a worksheet. If you use a link in the description, you can download the worksheet with the answers and with the working. If you don't do that, then you might need to pause the video to do the questions and pause the video at the answers. Mixture of questions. Sometimes find a side, sometimes an angle, and sometimes you start the question, you've got to realise you work out the missing angle first to make the triangle up to 180, or sometimes at the end, when you've got an answer to the sine rule, you've got to make the triangle up to 180 degrees. And that's the answers. If you downloaded the worksheet, you can get the calculations involved. We now look at applications, how to use the sine rule in questions. So this is two ships 49 metres apart. They're looking up to the top of a cliff. One ship at an angle of 60 degrees. That's the angle of elevation is 60 degrees to the top of the cliff. For the other ship, it's 40 degrees. This, when we draw the diagram, will be a horizontal line for the sea. It's not really the sea, it's the distance between the ships. So it's a horizontal line here. And if we look at the left-hand side of the diagram, there's a height here we were trying to calculate. There's a distance out from the base of the cliff to the ship. And there's this angle of 60 degrees, and that's a right-angled triangle. Now, we've got the angle, 60 degrees. We're trying to find out the height, but we need another piece of information. We need to know another side, which we don't have. So it's a problem. So we have a look again. What about the big outside right-angled triangle? Let's get the same problem. Height, angle, but we haven't a whole side here. We only get a bit of it. So that's not going to help. However, we've got a side here, 49. We've got an angle, 40 degrees, in another triangle using these dotted lines. Like that. That's 40 degrees, that's 49, that's a side and an angle, so that's an improvement. We also have 60 degrees here. And remember, it's the distance between the ships right out to the base of the cliff, so it's a horizontal line. It's not the actual sea, it's the line between these positions. With that being 60 degrees in a straight line, it's got to make 180 in a straight line, so the missing angle on the other side here, inside the triangle, is 120. And with 120 and 40 making 160, the missing angle at the top is 20. So we now get a triangle where we've got all the angles. And in particular, we've got a side 49 and opposite angle 20. That tells you sine rule. Now, that side is the same as that side. So if we work out this side here of labelled A, we can put it in the other diagram and we can use right-angle trigonometry, SOHCAHTOA here. So, we want to find A. We've got opposite 40 degrees. And the information we know is this side 49 and opposites 20. So we apply the sine rule. A over sine 40, that's that pair. And 49 over sine 20, that's the other pair, are equal. That's what the sine rule is saying. These ratios are equal. Multiply both sides by sine 40 and you get rid of it in the left. Or if you like, division by sine 40 becomes multiply by sine 40 on the other side. Put that in the calculator. Don't round it. It's 92 roughly. That side is 92. It's the same as that side. And now we've got enough information to work out h because we've got a right angle triangle, we've got the opposite to the 60 degrees, and we've got the hypotenuse. SOHCAHTOA, it's sine 60 is h over 92.089 and so on. So multiply the other side by that 92 and it solves for h. Using it unrounded, we basically take our last answer on the calculator and times it by sine 60, so it's unrounded and then we round it off. There's the height of the cliff. There's a worksheet with 6 questions like that. If you download the worksheet from the link, you'll get the answers in the form of the solutions to the questions. So it's the full solutions. The second kind of question you'll get in the worksheets are this kind where you're travelling distances. So you're travelling distances and you're using, for direction, 3-figure bearings. That's the angles. So in this example, ship travels from P to Q, 9 kilometres, bearing 125, there it's in the diagram, 9 kilometres from P to Q, turning clockwise from north at 125 degrees. From Q it sails on to R on bearing 260 degrees. So there it is, turning clockwise from north around 260 degrees. That's going from Q to R, but you don't know the distance. And when you get to R, the ship then returns to P on bearing 030 degrees. There it is there. Clockwise from north is 030 degrees and it returns back. And it says find the distance RP. That's this return distance from R to P. You'd work out this missing side. Now these kind of questions, the bearings give the angles and it enables you to work out angles in a triangle. It uses F or Z shapes, corresponding and alternate angles. And for parallel lines, and the north lines are parallel, for parallel lines, corresponding angles are equal, alternate angles are equal. You can use either, it doesn't matter which. I'm going to use alternate angles simply because the diagram gets less cluttered. So here we go. I've extended this north line. It's parallel to this north line, and there's a Z shape around the 30 degrees. A Z shape makes that 30. So there is a Z shape for parallel lines. Alternate angles are equal. That's a straight line down here, this north line. That's 125. This missing angle in here must make a straight line 180. It's a supplement, in other words, of 125. So that's 55. That makes 180 in that straight line. There's a Z shape around that 55 degrees coming down here and up with that north line. So you get parallel lines in a Z shape. Alternate angles equal. That's 55. Next, that's 260 degrees. That's 55. But there's a 360 degree turn here around a point. So the missing angle here must be 45. That makes up 360 around a point. Now you know that's up the corner here, 85 degrees in the triangle. That's 45 degrees. You can make the triangle up to 180. And all of a sudden we've got all the angles in a triangle. So now we've got all the angles and we've got a side in the opposite angle, so we can use the sine rule. It asks us to find out RP. So we need the opposite angle, the 45 degrees. So that's worked out the missing angles. Now, I said you could use F shapes. In F shapes, corresponding angles are equal when the lines are parallel. But more particularly, because a straight line is 180, this angle here is the supplement of A. That's 180 minus A. So if this was 30 degrees for A, that's 150 on the inside bit of the F. So you could have used F shapes rather than the Z shapes. For example, 125 and its supplement is 55. That makes 180. So you could get the 55 here from the supplement of 125. They're on the inside part of an F shape. The same way that's 30. So this angle in here around P, this angle will be 150. And together with that 125, you can make 360 around a point, and that would in one go work that out as 85 degrees. So you can use F shapes or Z shapes. F shapes I think are easier, but the Z shapes, it was easier to draw in the diagram for you. So what we have is 9 and the opposite 50, the unknown PR and the opposite 45, and we don't need the rest of the diagram. So there's the essentials we need. We want to work out A, opposite's 45, and we've got the pair 9 and 50 to be B, so that A over sine A equals B over sine B, and the A is in the top left. Take the 45 degrees up to the other side, put that in the calculator, and there's a rounded answer. And the side we called A was actually originally RP. Doesn't matter you write PR or RP, it was a return journey from R to P. So it's a distance in kilometres for this ship. Now there are 4 examples like that on the in a worksheet, and again it's got the worked solutions if you download the worksheet using the link. If you don't, you need to get it off the video. I don't want to spend time doing that for everyone, so what I'm going to do is as I start one of the worksheets, I'm going to show you there's a worksheet on the first example of applications. There'll be 6 questions, and then there'll be 6 sets of solutions. So you can download that from the link in the description. There'll be the second examples. So there'll be 4 questions like this using bearings, and then there'll be the solutions with the answers. Also using the link, there'll be a set of notes on the sine rule. Now, there are application questions, but we've only done the sine rule. There's still the cosine rule to go. So the applications in the notes involves sine rule and cosine rule. This one is fine. That's just the sine rule. So, set of notes, set of worksheets. If you don't have the downloads, then I'll go through the pause for a few seconds each page of the worksheets so you can pause the video. But if you've got the worksheets, you don't need to listen any further. So I hope you found the video useful. Thank you. That's question 1. And that's the solution. And that's question 2. And that's the solution. That's question 3. And that's the solution. And that's question 4. And that's the solution. And that's question 5. And that's the solution. And that's question 6. And that's the solution. That's the first worksheet in applications. The second worksheet, I'll go through the 4 questions and then the 4 solutions. You can pause them if you want to look at them. That's the first question. That's the second question. That's the third question. That's the fourth question. Now the 4 solutions. That's the first solution. That's the second solution. That's the third solution. And that's the fourth solution. And that's the end of the